Welcome. My name is Yannick Moy and I work at Educore. I'm going to present you the fourth installment of our Find a Bug series. First, I'll show you a piece of code with bugs, and secondly, I'll run our tool CodePeer on it. Here it is. We're playing Battleship this month. We've got friends, foes, and classes of ships. The protected type shortlist keeps track of shortlist of nearest ships that should be dealt with higher priority. There is a short list of friends and a short list of foes. Finally, each ship entering or leaving the short range is tracked by a dedicated task. Here is the implementation. Just below the 100 lines. If you want to beat CodePeer about finding the bugs yourself, just pause now and go to our website www.educore.com. Otherwise, let's call CodePeer on this project. Although it takes a few seconds, it returns probably faster than you could review. And here it is, with a summary of the problems found. It reports 1 high rank warning and 6 medium rank ones. In the first and the second warnings, CodePeer reports that the accesses to saturated combat zone in procedures add ship here and remove ship here do not rely on a command lock, hence the unprotected success messages. The pattern here is some shared data that can be accessed concurrently, thus creating a race condition. If we look at the code, we see indeed that add ship and remove ship may both modify variable saturated combat zone. Now these are procedure in a protected type that may only be called concurrently on two different instances of the type, which is the case here with friends and foes. Saturated combat zone is a global variable which may indeed be modified in parallel by two calls to add ship and remove ship on these different objects, friends and foes. The correct behavior here is to make saturated combat zone a field of the protected type. So that now each shortlist maintains its own Boolean status. In the third warning, CodePeer reports that the right-hand side of the assignment might not be positive or null, which is required here to assign to num and tracked ships. If we look 3 lines above, we see that the code tests for the nullity of num and tracked ships. In the case that this test succeeds, the right-hand side here becomes -1. So CodePeer is right to report this possible error. The problem is simply that we put the statements in the wrong order. The decrement should be performed before the test. Like that. In the fourth warning, CodePeer reports that index might be uninitialized at the point it is read to access array ships. Indeed, it is set to the index here of the biggest tracked ship. So what if there are no such ships? We should detect when index is assigned to and raise an exception when it is never assigned in the loop to see now that no biggest ship was found. So let's do that. For example, by giving a default value of -1 to index and detecting this value before accessing ships. Let's now rerun CodePeer. Done. We still get 1 high rank warning and 1 medium rank one. The medium rank warning is a false alarm. CodePeer is not clever enough to figure out that index is within bounds at that point. Here. After we review it carefully, we can save this review for future runs. So let's do it. The high rank warning is not an error, and the task should indeed keep looping. Again, we can save this in a manual review. With this additional review effort, this time again we got no more warning. If you enjoyed this demo, please go see on our website www.adocore.com what else CodePeer can do for you. Thanks.